Hi, everybody. This is Lois Arena and Monte Paulsen at the NAPHN Conference 2020. We're going to be talking to you about hitting milestones and budgets today. I'm going to kick off first with just a brief introduction of my firm. I'm from Stephen Winter Associates. We have offices in New York, Connecticut, Boston, and DC. We are a building energy consulting firm, and we do everything from energy consulting, sustainability, energy modeling, high performance, passive house, net zero, accessibility consulting, anything that has to do with buildings. And we deal with both existing and new construction projects. And we also deal with everything from single family to industrial buildings. So we sort of cover the gamut when it comes to your buildings and making them perform better. What I would like to just show you really briefly is not like how successful we are as a firm, but just to sort of give you a feel for how passive house is actually ramping up in our market today. And, you know, we started back in 2010 when we were doing this, and we really weren't on the map yet until about 2014. And then ever since then, our projects have been increasing exponentially. And I can tell you this presentation slide here was last done in February, and we're already over probably the 9 million square foot of passive house projects to date. And so it's still going, it's still becoming one of the more viable high performance standards that's out there. And as you can see on the scale on the right, or the legend on the right, it applies to just about any building type out there. So that's what we kind of want to give you the feel for today. It's not just that you can do it on multifamily or housing, you can do it on any type of project. The concepts apply. We've got everything from schools to dormitories to commercial office space, hotels, everything applies. As you can see, the bulk of it really right now is in multifamily particularly, but it spans the gamut of building types. As far as multifamily goes, we're reaching over 7,000 units today in the market that have been or are in the process of being certified. So we're just really would like people to feel comfortable that this standard can be applied to just about anything in any climate zone. This is what I like to refer to as my therapy slide. You can do it. You know, it's all the types of buildings I just talked about. Where I have everything from our affordable high-rise multifamily mixed-use projects to market rate projects that are high-rise to low-rise affordable projects. The picture here you see in the center is actually a retrofit of an industrial textile factory in Sri Lanka. So all climate zones, as I was saying. And then on the right, you're looking at over 1 million square foot of office tower that we're going to be doing in Boston that's under construction now. So if you take anything away from the thing today is we're out here, we're working on it. It applies to all building typologies, new and existing, and there's ways forward for you if you're interested in doing this. Monte?
Thanks, Lois. My name is Monte Paulsen, and we do similar work. RDH Building Science has about 250 people, and we're an employee-owned company. We work in offices in the US and Canada. And somewhat similar, we're doing about 5 or 6 million square feet of passive house right now. We do a lot of mass timber work, including facade engineering for taller buildings, life cycle assessment. We have our building science laboratories in Waterloo. We do future climate assessments, and we do a lot of renewal and rehabilitation. We learn from those existing building projects and apply that to our new building projects. I think you're going to go first, Lois, so back to you.
Thanks, Monte. We're going to throw you guys back and forth a little bit just to make sure you're awake through this presentation. I'm going to start with what our process for success is from beginning to end of a passive house project. And so here you'll see the typical project timeline. And it takes you right through from schematic all the way through construction. And what I'm going to do is sort of walk you through where passive house and where our processes fall and what we do at each key milestone in this process to make sure that your project is successful from beginning to end, and that you don't wind up at the end saying, well, what happened? Why didn't we know that we needed to do this? Or how come that didn't get checked? So here's sort of the QAQC sort of steps to make sure that you most cost effectively reach your project goals. So schematic, we all start at schematic. Passive house from the beginning is an integrated process. It's an integrated design model. When I first started with passive house, that's just sort of naturally how it started off. We were working on Cornell. The whole project team was at the table from the very beginning, the CM, the architects, the MEP, the facade consultant. And as we went through our next few passive house projects and I started to hear people talk, they talked about integrated project management. And they started to talk about this process. And I'm like, well, that's so strange. Doesn't everybody work that way? And no, apparently everyone does not work that way. But if you're on a passive house project, you most certainly should and probably are working that way. So everybody's at the table at the beginning. That's the way towards the most cost-effective solution for your passive house project. You want your construction manager saying, there's a sequencing problem here that's going to cost money, or we'll have a better way to do that detail. With your architect saying, well, okay, but we can't do that. With your structural engineer saying, no, you're going to have to fix that. That's the best way to ensure cost-effective design solutions to reach passive house for any type of building. So you really want your team there forward. Now, sometimes you can't do it, right? Sometimes that's not the model, but that's okay. You can still do it in other models where you can't bring your CM on until after, but there's ways to make sure that it's a successful process then. But this is the typical standard successful project management strategy for passive houses, integrated design. And so at this point here too, this is usually where we do, you would think this would be a little bit too soon, but this is usually where we do our first sort of major 3D thermal modeling of the wall assembly, because the team generally knows what the construction methodology is going to be, and they generally know down to one or two selections for what their cladding will be. And the architect needs to know immediately, the project team needs to know, how thick does my wall have to be? So when we do the schematic model, we kind of come up with the recommended efficiencies for each of the different components in the building. And we can take that wall and we can say, well, if we said in the model, in the schematic, you need to get up to an R30 wall, just for an example, we can take their building structure and their facade and their cladding attachment, and we can model that and make sure that the attachments and everything like that result in an R30 wall. And then we can say to the architect, go ahead, this is the thickness of your wall, and then they start their floor plates. Because usually in these larger scale projects, especially that Monte and I will be talking about, you're usually at lot line issues or side building issues and things like that. So your wall thickness will dictate your floor plate. So that's a very important first part in schematic. And so really will help reduce any changes that need to go through in your floor plate design and layout. And again, as I said, the CM is invaluable. They're going to provide really important cost information and sequencing information at the beginning and tell you what's more constructible. The more constructible it is, the quicker it is, the cheaper it is, right? So very important to have them on at the beginning. So then we move from there into design development. We're figuring out at 100% DD is when passive house sort of steps in to do their next major analysis of your project. Not that we're not at the table talking to you throughout and saying what's possible and what's not, but once you set those floor plates, once we get those layouts set, then we take that building and we create a more detailed energy model. And we confirm that everything we said in schematic is still in compliance. You never know, your window percentages may have changed or things like that change. So we're going to make sure that everything is still in compliance from what we told you. We're also going to start to do some critical thermal modeling depending on some special details you might have. Like you might have an overhang that you want to incorporate, or some cantilevering that we didn't know about in the schematic. So that sort of stuff will get looked at very carefully so that the CM knows what we're talking about for thermal bridges and things like that, and any special materials that they're going to need to order for the project. This is also at the time when we're first going to engage with your passive house certifier, the certifying body that's going to give you the rubber stamp at the end that says, yes, you did it. And they're very similar to, for those of you who know LEED, it's very similar to the USGBC. Like you will work with a project design team to help you check up all of those things off your checklist. But in the end, that whole checklist goes over to USGBC. Well, it's the same thing for passive house. That whole checklist, everything we're doing, all the documentation, all the modeling has to go to the certifier. So that's where we first engage with them, because we want to make sure we didn't miss anything big. And if you have a unique situation on your project, we want to get their approval for the way we have decided to go through it. This is the time to get that approval, right? You don't want to wait till 100% CDs and the certifier says, hold on, we don't approve of that. So this is when we usually first engage with our certifiers. And then I always say QAQC starts in design development, right? It's where we decide where your air barrier is going to go. As you know, passive house has a really stringent requirement for air leakage. So this is where you actually start saying, here's my strategy. It's going to be on my exterior gyp. It's going to tie into my roof this way. It's going to tie into my foundation this way. And it's going to tie into my windows this way. At what locations? And you have your major systems already in your head about how you're going to, what section and what portion of the building, what surface of the building is actually going to be part of your air barrier. And that's how we move forward with that as we go through design. So then after that, and I'm sorry, this is an example, excuse me, this is an example of that air barrier review, a typical air barrier review. We go into your sections and plans, we circle every connection where you either change direction or material, and we say, what is your detail for connecting, or not what is at this point, if we're in design development. We are going to need a detail at this section that shows me exactly how your roof connects to your wall, what material is going to connect, and honestly, who is going to do that connection? Somebody has to buy that work, right? Is it your roofer? Is it your wall air barrier contractor? Because they're not the same person. So this portion doesn't only just tell you, okay, what's the material and what's the sequencing, it also tells you who's responsible. So you can make sure that that cost gets in the bid and that that's not an add afterwards, once we've got our budget all set and then somebody says, well, that wasn't part of my job. So this is a very, very crucial step here in identifying all of those critical junctions. Okay, so now we get into construction documents. From our perspective, for the plans that we see on these large scale projects, this is where we get into the nitty gritty of our mechanical plans. This is where we finally start to get detailed drawings and riser diagrams and flow rates and things like that on the drawings. And this is where we also see the majority of our building details completed, our junctions, our window to wall details, our roof to wall details. This is where the architect really dives in and gives us those up close and personal details. And so, we dive in. So we don't just do one review of the CDs. We do a 50% review and then 100% review. Now, it's not exactly those. Sometimes people do a 90% CD set, whatever works best for the team. But there's typically 2 reviews is all I'm trying to get across to you. And so we do a review of the air barrier connections, as you know, a moisture barrier and all of that stuff that gets reviewed here. But we also now start to do comprehensive thermal modeling of all of those connections so that we can make sure that we have no condensation issues, no dew point problems within the assembly, no condensation potential on the inside of the assembly, say at the windows where they connect to the wall. So this is really where we start the bulk, the majority, the remainder of all of our, probably 75% of all of our thermal modeling is performed in the CD set. We also start to create our QAQC tools and processes for the field. So we're going to start to say, all right, here's my checklist of items I need to see when I'm coming out for inspection so that you cannot cover them up. So sometimes we have unique conditions, sometimes we have regular conditions. So a unique condition might be on the roof I have dunnage and I need to put a thermal block between the roof concrete and that dunnage. That's going to be an out of sequence thing that only happens once on the roof, you know, at one point in construction. That dunnage is going to put, the blocks are going to get put down on the dunnage. So I need to make sure I see that. Then we have repeating systems, which are like the window installs. They go up the same all the way through the building typically. So I just need to make sure, you know, I'm going to be reviewing those on a floor by floor basis. So there's these checklists get created. We also start to talk to you about the intermittent, how many inspections we're going to do, not only what we're going to look at, but how we're going to test that they're performing well. And so we'll create a whole list of tests that we recommend for your particular project and at the specific locations that we may be concerned about that need to be done well. And we want to make sure they're done well at the beginning of the project so that they can repeat those details as they go through. We also look at the blower door test plan. Now, at the end of the project, you all know this, at the end of the project, we do one large building blower door test typically. And so what we need to do is create a plan. It's a pretty complicated test. It takes the majority of a day and a half to get set up and conduct the test. And so we want to make sure everything is in the position that it needs to be in. So we need to identify people who need to be on site. We need to look at what needs to be closed off and what can be open. This blower door test plan actually is part of our QAQC process. And what it does when we do it in CDs, it allows us to see if somebody snuck something in there that shouldn't be in there, that would be against passive house. For example, the MEP threw an exhaust fan in a room that we didn't know they were going to put an exhaust fan in before because it wasn't on previous schedules. And now you've got an exhaust only fan on a passive house project that we can't account for, that we can't use, that, you know, needs to be changed out. So this actually helps us identify these things instead of waiting till we get on site and it's already installed and then we're like, what happened? So the blower door test plan is a very useful QAQC tool, believe it or not. It may not sound it, but it's caught a number of things on many occasions. And then we also do your specifications review during this period. And that is to make sure plans match specs on everything that is really highly related to Passive House. What do your window details need to be, the specifications for every junction in every particular type of window in that building, every fan, everything. So we're going through all the energy related specifications for our Passive House review. So here's a typical riser diagram, right? But what I also want to tell you is, we're going to talk a lot about cost in this presentation, and nobody ever says, well, what does Passive House save me? And so it's more than just energy savings. We have on a number of occasions helped the construction team reduce materials in the field that have resulted in dramatic cost savings and as on top of energy savings. So I'd like to just give you a quick case study. This is Sendero Verde. This is all three buildings are part of Sendero Verde, but this is the main tower. This is a 37-story residential mixed-use tower. There's 4 stories of retail in the base and commercial. There's 384 dwellings on here. I'm sorry, I forgot to put the gross square footage in. It is about 350,000 gross square foot of conditioned space. So what happened was when we got the mechanical drawings and we started to look at the domestic hot water, what we noticed was what we consider a 3-pipe design. I don't know if that's the technical term. Is that now this engineer is a very good engineer. I'm not saying anything about him, and this is a very reliable system that they created. And what it is on the recirculation piping, that they had a riser going up for a stack of apartments that would be on that riser, and then the return loop from that came down, and it did that for every single riser loop for every stack of apartments that it was serving. The unfortunate part of this is an incredibly high amount of piping. And the more piping that you have with domestic hot water, the more heat loss there is to the space, which increases cooling. It also decreases the efficiency of your domestic hot water system because you have all of that heat loss. So what we wanted to suggest and what we discussed with them was a typical box design. You basically have one riser going up, the supply riser that feeds the stack of apartments. You have this one supply length along the bottom like you did in the other one, and then you only have a simple supply loop back to the water heater. Now this can be flipped where the water heater's in the basement, but basically you've eliminated all of these extra risers that are running up and down the building on that return loop. And this reduced the distribution piping by 40% on this particular project. It's a very, very tall building. It decreased the pumping energy, it reduced material cost, and it reduced domestic hot water heating costs. That was about 10,000 linear feet of copper tubing, if you can imagine the amount of savings from that. Now, the concern that the engineer has was balancing for this type of system. They prefer the other one because it's a little easier to balance, a little more self-regulating. This one, however, at the top, you need a thermostatic valve at the top. That's fine. They felt comfortable with that. Once they talked to the plumbing contractor, they were like, this is a very typical design. And once we did this analysis, everybody was on board, the plumbing contractor, the MEP, and the owner in particular, because they were going to be saving so much money. So, this is the type of thing that actually doing Passive House is a benefit financially. It's not just always a cost. What am I adding? So they switched to from the 3-pipe to the box design. It saved, as I said, 10,000 linear foot of recirculation piping. It was an 18% reduction in the domestic hot water heating energy demand, and it was a 16% reduction in cooling. So this is a pretty drastic improvement in energy efficiency that also results in a cost savings to the owner, to the developer. Okay, so that's construction documents. Then we get into pre-construction, right before we start construction. And this is where the estimating and the bill reviews come into play. And your Passive House consultant, believe it or not, is involved in this, should be involved in this, and can help you, again, make sure that everything is complete and that you're saving money here, because the unknown always results in a oh my God factor in a pricing, right? I don't want to say the swear word, you know what it is, but so what you really want is you want your energy consultant at the bid buy meetings to ensure the scope is understood by the contractor. We've had many times, and I'm going to give you some examples later on, of contractors adding costs because they don't really understand the Passive House process. And when we review the estimates, we're like, no, this isn't going to be a problem. You can take this out. This never happens. You can take this out. So it's very important in the bid buy meeting to sit down with the subs that are going to be bidding and explain the actual scope of work and let them ask questions so that they make sure they get everything. You also want to make sure that they get everything. A lot of times they assume it's a typical building, even though you tell them it's a passive house, they don't realize that something in their scope or in that spec is very different from what they're typically seeing. And they don't bid it, and we don't, and nobody catches it. And then at the end, it's considered a change. So, you know, a change order, and you definitely want to minimize those. Everyone knows that. So we want to review the contractor bids. We want to be part of the bid buy meeting, and we're also going to review the submittals to make sure everything matches. You know, it happens time and time again where the submittal is not meeting the performance of what was in the specification, and you'll get, well, that's our typical, and you're like, well, no, that's not what's in the specification. So we really, it's a really comprehensive process when you're part of a passive house project. So this is just an example. We created some guidelines for bid buy meetings. We did this for another project that we were working on, but you know, we think we're going to start using this on a regular basis with our contractors. It's fairly new, but basically we created a set of checklists for the different components of the building that are most affected by passive house, by high performance in general. And so, you know, as I said, highlighted in yellow here, it's really crucial that the subcontractors understand the difference between this type of a scope and what they're normally used to bid. All right. And the general topics that we cover in this checklist include air sealing, insulation and thermal bridge mitigation. So any specific materials that actually need to go in under, like I was saying, the roof dunnage, add any wall cladding attachments, things like that. They need to understand what we're asking them to do. Ventilation design and controls. Controls are very important. Make sure they get into the documents. And then domestic hot water design and installation, as you just saw. We actually have a lot of problems with the wrong thickness of insulation being put around the water pipes, the hot water pipes. So it's really important to make sure that if you're going above code, or even just making sure they understand the code, sometimes they'll say, well, we always put this type of insulation on this pipe. And you're like, well, no, the code in here says you actually have to use this. So making sure that whatever they're installing in the field matches what was modeled and matches what was in the specification is really important. This is just an example. So this is we do a pre-construction kickoff meeting. And these are an example of those checklists we were talking about, where we go through the plans and specs or excuse me, the drawings, plans, sections and details, and make sure that we call out anything that we're going to need to see that's not typical possibly in the project. This is a very atypical detail that was on this particular project. So we had to call it out and let the contractor know we would need to be inspecting this detail. So we go through during the construction kickoff, we go through the inspection checklist with them. We tell them what our intermediate testing plan is and what the blower door test plan looks like and who will need to be on site, and that we will be revisiting that blower door test plan when we get closer to the end of the project. You can't expect everybody to remember that sort of stuff, but it's just a good eye opener at the beginning of the project that this is all happening, and the subs need to know that that's happening. And we also do an MEP kickoff with our HVAC subs, because it's in the drawings, it's in the specs. They're not used to doing passive house, and so we need to make sure they understand the requirements of the mechanical system, the controls, placement of exhaust vents sometimes is incredibly crucial, have to be a certain distance away from certain things. So we want to make sure that the HVAC subs are really on board with what needs to happen. Okay, so finally, you're ready. Everybody's up and running. This is where our QAQC actually kicks in. This is where we start we're doing our contractor trainings. We're going to do mock-ups. So we're going to do things like that in the field for the actual trades in the field. This is when we start our site inspections of all the insulation and all of the passive house related issues that we need to make sure we're confirming and taking photo of. We also start our intermediate testing, our mock-ups and our window testing, and any other component we're worried about is air leakage. We start here. And then we also attend meetings and provide additional support to handle things like RFIs. Okay, how is this attachment really supposed to work? Or, you know, I can't get this insulation in there. It's too thick. Can I use a thinner insulation? And so this starts this process. So there's always a portion of additional technical support during construction that we deal with. This is just the picture is just an image of a mock-up test for window. So this is what we call some interim blower door testing. Because for large projects, you can't stop the project halfway between, you know, once it's dried off at the top and just do a whole building blower door test before they drywall, because that's not how it works. Drywall starts at the bottom before they're even finished at the top. So we had to find mechanisms to test things as we went along. And interim window mock-up testing, envelope and window testing, any unique components like trash chutes or odd things that we're worried about, we can test as well. You can test a whole floor at a time with a guarded blower door test if you're very, very concerned. It does take maybe a day or two away from some of the construction staff because we sort of have to shut the site down at least on those floors. And so, but it's a very useful test to kind of get, if people are uneasy, to give them some peace of mind. And then at the end, we do the final whole building blower door test, which is what this looks like. And everything's hooked up to our trusty computer. All the fans are tied in, and we pressurize and depressurize the whole building at the end to make sure you've met your goals. But this is like the last step. This is a cherry on the cake. You've done everything you needed to do at this point. You've got all your inspections. You've got approval on everything. You've done all your interim testing, and your contractors have learned the whole way. And then at the end, we do the final blower door test. So Monte, that's my spiel. Back to you.
Thanks, Lois. That was great. I really agree with timeline, the focus on early involvement of design, early involvement of the certifier, and the real focus on kickoff meetings with specific teams. So important. Okay, so how much does it cost to do all this? We do work on large urban buildings, such as those Lois has shown. We also work on a lot of affordable housing projects, wood frame mid-rise. We see that development cost, typically accounts for more than half the building, and construction costs less than half the building. And we note that operational costs can be a bit lower in Passive House. You have lower utility costs. You may have lower maintenance costs, depending on how it was designed. And for many developed Passive House projects, the monthly operational savings can exceed the slightly larger mortgage on the project. And so it's important to note, construction cost is only a portion. At the low end, we see projects around $250 a square foot, not just Passive House, everything. And at the high end, towards 500. And a 5% construction cost increase on that low end is still only a 2.5% total cost increase. And that 5% construction cost increase can be as little as 1.something% of the larger building. Nonetheless, the question I get almost every single day is, how much does it cost to build a Passive House? And they're looking only at the build costs. So let's answer that briefly. 3 studies I'd like to show really quick. Passive House Trust in the UK has put together a study, and they found, this was just released last fall, so this is fairly current, about a 9% more than baseline in the UK. Here's a graph of the buildings they looked at. You can download this from the Passive House Trust website and pore over the details yourself. Just to put those numbers in context, 1,500 pounds per square meter is approximately 172 US dollars per square foot at the current exchange rate. Now I would note most of these were built over the last few years when the pound was a little stronger. A second cost study that we reference here in British Columbia quite a bit is when we introduced our STEP code, we did some studies on how much it was going to cost to do this. Now, the STEP code is not exactly the same as Passive House. By 2032, all of our buildings will be at a 15 kilowatt hour per square meter heating limit, very similar but not identical to Passive House because the floor space is measured differently, and a total energy limit of about 100 kilowatt hours per square meter. So similar but not identical. That study found that to get to those step 4s in most of our climate zones was about a 2 and a 10% premium. We would say that's been consistent with what we're seeing in Passive House. Our first larger multi-unit Passive House here in Vancouver had about a 5% additional construction cost. Now, again, that building is paying off. The overall operating costs are very low, but it had about 5% build cost. By this year, we've seen this project at step 4 and a couple of other Passive House projects that are coming in pretty much at par with the construction costs in the area. I would add that the Vancouver Zero Emissions Building Exchange, or ZEBEX, is surveying construction costs, and we hope to have a more in-depth report on construction costs for buildings in our region to be published later this year, so please stay tuned. And the third way to look at custom costs is some data from Pennsylvania. In 2015, the Pennsylvania Housing Finance Agency added 10 points for Passive House projects to their scorecard. And what happened that year was they got a whole bunch of submissions. Here's some graphs that were put together on this. And the Passive House proposals ran about 2.5% higher than the non-Passive House proposals in that year. Interestingly, however, by 2018, the awarded Passive House projects ran about 2% less than the awarded non-Passive House projects. So you're seeing at these affordable, focused, mid-rise, typically wood frame Passive House multi-unit buildings, we're very, very close to other construction costs. And I just want to look at 4 quick case studies in case you're still skeptical. And I chose ones around North America since this is, after all, a North American Passive House project. So the project we just looked at in Vancouver, 85 unit market rental. This had the difficulty of not originally being designed to Passive House, but being converted early on. That generally drives up costs quite a bit. This in US dollars was about 170 bucks a square foot. Had a really simple wall assembly designed to require as little trade change as necessary. The trades framed and clad the building the same as any other. Really simple interior installation strategies at the parkade and the commercial levels. Really simple mechanical systems, not that different from mainstream practice at the time. Pretty typical fit and finish for this mark. About 225 Canadian, again, about 5% construction premium. Portland, Oregon did a great project about the same time. Orchards at Orenco, some of you have probably seen this. This was about 158 US per square foot in 2015. Pretty simple form, simple mix of a thick wall and a little exterior insulation to limit the thermal bridging. What's really interesting is the same project changed its design for its second phase. And on phase 2, they had a higher per square foot price, but a lower per unit price. And so they actually produced more units for less dollars by redesigning the units a little bit. And this emphasis on elegant, efficient design that both saves money in construction and makes the building more efficient from an energy perspective is a big part of what we're working with an awful lot of nonprofit and market rental developers to do, to find ways to build Passive House for less. Philadelphia, Capitol Flats in 2017, 169 per square foot, including some solar. This used the prefab wall panel, the smart panel system, as quite a few of the really affordable minded projects have. Simple windows, simple form, simple central HRVs. Those 2 HRVs serve the whole building. And 25 one-bedroom suites for about 169 per foot, or 146.6 per unit. I assume NAPHN is sharing these slides, so if you feel you can't take notes fast enough, we'll come back. And then final kind of a cost winner is Bayside Anchor in Portland, Maine. A really simple, thick, blown insulation, super simple form factor. This is an infill project in an existing affordable housing development. As you can see, really simple, affordable housing. So simple, they didn't even put cabinet doors, on in the kitchen, but a perfectly nice unit in a fantastic neighborhood in a great city. Really simple mechanical systems. Central service area that served other buildings as well as itself. 149 bucks, 150 a square foot US. It's personally, I would say it's possible to accept a lot of sort of adjustments for those prices. So you look at these 4 projects, and we could have picked another 4 from the same time. We just had to kind of draw the line somewhere. 170 to 149 per square foot in 2016, 27, 2018 range. The market standards across the US in that same year, as reported by RS Means, are in this range. Kind of 169 to 223 per square foot, 261 the high in Chicago. My point being that all of these developments and quite a few others were at the par for regional affordable housing rates during this time, and we can still do that even in the difficult economy we might face going further. With smart design, Passive House or near Passive House projects don't have to cost more. Back to you for just a few look at costs on your projects, Lois.
Thank you, Monte. That was a really great summary of some of affordable housing. I'm going to take you to like New York City area, the Ritz-Carlton of affordable housing projects. Our prices, I don't have the ranges here on this slide because we're trying to keep most of these information anonymous, but I have 16 projects that we were evaluating, all of which are large scale Passive House projects, except for one. They're all over 35 units per building. The large ones are like 50 to 150 square units per building. The extra large are 150 over, so somewhere in that range. So really large projects. The price per square foot on these buildings in Manhattan, in the boroughs, are more like upper $300 per square foot to close to $700 on some projects. And what I'm showing you here right now is the average increase in the 4th column here to do construction over Passive House, okay? So anywhere from 1 to 8%. And I've highlighted those projects that have had Passive House experienced team members on them. And if you'll look, you can see every single one of those was either 5% or less increased cost above their baseline. The two in blue are dormitories, so they're not an exact apples to apples comparison to the other buildings, but they are highly dense. The thing with dormitories is they typically have a very high base cost because they're going to put in higher end mechanicals usually than a standard single family, or excuse me, a standard multi-family affordable project. But anyway, I just wanted to pull those out just so that you could see, but still in the 3 to 5% range of their budget. The ones that are higher have either an inexperienced builder that does not have Passive House experience, and it has that fear factor included in the cost, and said added time to the construction period, to the construction duration, which is not typical at all for Passive House, but they still put that in their estimate. The other one of them at 8%, has a very, very complex facade, lots of surface volume to ratio, lots of twists and turns, and a very high-end facade to begin with. So theirs was a little on the higher end. And then the last one was a builder that just came to us and needed a quick feasibility for something that we were doing, and they just sort of threw a cost at it, like somewhere between 6 and 10%, something like that. So we gave the average on 8% for that team, but once they get into it, I think they'll see their project is not that complicated and that price will come down. But very consistent with what Monte was showing in the price increase for Passive House. Now you have to keep in mind, several of our builders, when we were talking to them about the survey, said, you know what, we don't price a building as non-Passive House and Passive House. We have a project and we price it at Passive House. Every building we do is different. It's going to cost a different amount of money on a different site. They all have different challenges, especially in these, urban areas. So it's not like we really know. They're like, isn't it just about quality? And shouldn't quality be part of an affordable housing? So it is a very interesting set of comments that we got back from them. But of that subset of buildings that I just showed you, here's the range of the certain characteristics that I wanted to show you. So we ranged from 30 units, which are by far our smallest, to 385 units in the largest. On average, we have 184 units per building, and that's a pretty good number. Gross square footage ranged from 33,000 to 386,000, so 10 times larger. We had anywhere from 6 to 37 stories of building, and then the increase for Passive House ranged from 1 to 8%. Project costs, total project costs range from about 12 million to 233 million. So I'm just trying to give you a feel. And you can see here's that cost per square foot range that I was telling you about, $300 per square foot up to $832. So a huge range. The average on that was about 527. So, just massive increase in cost. And anytime you go above a certain number of stories, you really increase your cost per square foot for your project anyway. So that's a fact of mid to high rise construction. What I wanted to do for you here was just quickly try and see what building characteristic was actually going to increase the cost the most. Like, what was the biggest attributor to cost increases? Was it number of dwelling units? And so I mapped out, all the buildings and the number of dwelling units they had from, the 30 to the 383. And what the percent increase is, the orange number. Now, the red bands are the outer limits that I gave you, about 1% to 10% was our min and our max that we got for estimates. And then the orange is the actual, what they estimate. And you can see it's really all over the map. There's really no correlation. And we know that when we do this scatter plot over here, when we map number of units against percent increase, there's no nice organization, right? If there was a correlation between number of units and average increase in price, we would see some sort of nice line or some sort of nice curve that we could put an equation to. This is like buckshot. This is all over the place. So obviously it's not a one-to-one relationship with dwelling costs. Number of floors, we did the same thing with number of floors. As we get taller, does it get more and more expensive to do Passive House or less and less? Again, you'll see all over the place with these numbers, and buckshot again. So no direct correlation to height of the building or number of stories. Finally, I said, well, what about gross square footage? That's got to have something to do with it, right? We always assume the bigger the building, the less impact that Passive House will have on a building. Do you see any direct correlation here between square footage and Passive House? Nothing, right? If we would expect building square footage to be less as it got bigger, the percent increase to be less, we should see a nice sort of decreasing percentage come down this way. Once again, buckshot. So there's no one direct cost. Now, what I will tell you is these are the main factors, right? These are the biggest cost contributors, and everybody we asked, The top 5 are the top 5. This is what they said added in cost to their project. HVAC, the standard VRF system over a typical PTAC in a high-rise building, that's going to add cost. ERVs, the addition of the fresh air supply to all the bedrooms, and some of the controls. The ERVs themselves are a little more expensive than exhaust fans, but then it's really the addition of all that sheet metal work that has to happen. Windows, we are typically seeing the increase from a good double pane window to a good triple pane window. So that's the cost increase there. Insulation, added thickness. This is a little bit arguable because in some spots maybe, but on a really well-designed passive house building, a nice surface to volume ratio, we're not looking at insulation values that are much, much higher than code. It really comes down to the detailing and the thermal bridge mitigation. What special materials do I have to use to separate my cladding attachments and that sort of thing, right? And then the additional air sealing. And honestly, I think this is just where the scare factor is. People hear that contractor hears that, they need to be 10 times tighter than their code, and there's an additional cost on it. When really you can do air sealing with your typical materials. It's just the attention to detail. And once the contractors actually see what they need to do, it's just a matter of completing that air seal in a more complete way than they're used to. I think that cost is going to sort of go away on us. So that's one of those costs there. So the questionable ones that we heard was training of construction staff. And to an extent, yes, but it really is part of what we usually do. And we've had teams hire a special air barrier, air sealing consultant, and we've had teams that haven't, and we've passed the blower door test on both ends. So really, I think this is a questionable cost that people are just afraid that they're going to have to do. And then construction delays, like I said, they're very rare. You really shouldn't have a construction delay unless it's a very unusual situation. And it's usually not passive house related. So I just want to do this, and then I'm going to pass it back to Monte. We asked for comments from the owners, and this is one of our repeat passive house developers. And basically it comes down to, he said in his mind, the only real difference between a passive house and a non-passive house, with the exception of the balanced air, is quality. And shouldn't that be part of every project that they do? And if someone said, he said, if someone would say it was 5% more, if someone would say he said, if someone would say it was 5% more, I would agree. If someone would say it was 0% more, I would agree. He said, but if somebody said it was more than 5% cost premium, he would say probably not, because the quality it's really just quality that you're changing, and that should be part of their standard procedure. So that's my spiel on costs. We're going to send it back to Monte to finish this up for you.
Thanks, Lois. That's fantastic. That focus on quality is so important. So, like you, I sit in a lot of meetings. I meet a lot of customers. I watched many processes unfold. Some are fantastic and efficient. Some are a little bit of head scratchers. And I've been asked more than once, if I were the developer, and I'm not, I think we're all grateful for that, but if I were the developer, if I were the owner, what would I do differently? And that's what I'm going to try to answer here. So if you've been looking at this, I assume the question you're asking yourself is, how do I be the project that has a 0% cost premium rather than a 5 or 10% cost premium? So I'm going to try to answer that. So think of it conceptually this way. This is the cost to build the worst building you're legally able to construct. And in some sort of funky way, we're calling that our baseline. And I do want to be clear, if you take the exact same design as the building you might have built alternate and cost it as a passive house, it's going to be more. You're going to put more on it without taking anything away, without changing anything, without rethinking anything. So if you build the same design with no awareness of change to the passive house standard, you should anticipate 105, and we've seen 1 or 2 up near 120%. But you wouldn't do that. You're not going to take a pre-passive house design and build it to passive house standards. You're going to redesign the building and rethink the process, as Lois and I have been trying to describe. Think of it this way conceptually. First, shrink the building, lower that baseline cost by being hard at the front end, by really asking, do I need all of that glazing? Do I need that jump out? Do I need this, whatever the feature is? Limit the window and wall ratio, reduce the enclosure surface area, demand compact mechanical cores, triage step backs and balconies as much as possible within your jurisdiction and your purposes. Make the tough choices before you hire your architect. This is your job as an owner or as a developer. Put your tough choices, your metrics in your owner's project requirements. And I want to point out, that's the document. This is your opportunity, and that's you pushing back on these things. You're the only one who can do it. It is not going to work asking your project team to cut 10 or 20% out of something. It's the owner's job, and the owner can do it most powerfully at the beginning of the process. So having reduced the baseline costs, then you can add back some of those things Lois just pointed out. A little bit of extra insulation, triple pane windows, the mechanical systems that drive these large multi-unit or other complex use passive house projects, the quality assurance and certification processes, all those visits Lois talked about, those cost money, those cost time. Add back 3, 4, 5% for those above your carefully redesigned building, and you are still ahead of your original costs. And what I've seen the best projects do is they get really hard at the front. They add the minimal additional cost for passive house, again, making this approach clear in the OPR. And then with the slack they've got left, they put in what they love. They put in what's important to them as a project. Maybe it's a big bright stairwell under a skylight. Maybe it's a photovoltaic pergola over a shared roof deck. Maybe it's real brick cladding or some other kind of feature, but they take all of that stuff out in the baseline so they can get to where they want to be. This approach works. This, whether formal or informal, is the approach that each of the projects we showed earlier, those 4 very cost-effective projects, followed. So you might ask, what should you put in owner's project requirements? And I just want to say there's a good example of an owner's project requirements on the ASHRAE site. They created owner's OPR for their own headquarters. It's quite detailed, and it's a good example of a great OPR document. You're welcome to Google it. A not such good example is this, and I'm leaving it anonymous, but here in the OPR, the early documents are saying, well, we're not going to pursue any certifications, but we want this program to exceed Passive House, to exceed Net Zero Plus, and to exceed Living Building Challenge without certifying or doing any quality control to anything. And I do see, this is a real document, and I apologize if you know who it is, but I do see this kind of approach routinely from owners. This well-intentioned owner has not made the hard choices. This owner has not done the pushback before bringing the consultants aboard. And this owner will struggle with costs all the way through the project as a result of not being disciplined at the front end. So what would you put in? I just want to list 4 things that I would put in if it was my project. I would demand that the project lay out mechanical first. I would demand a minimum surface area given the rest of the project. I would force the facade to follow function, and I would set a target for window to wall area that was appropriate to the project. And I would repeat what works and look for creative repetition as much as possible. And I'd just like to share a few thoughts on each one of these ideas. So Lois showed those slides of where these things cost more, and the first 2 were mechanical. Remediation of poorly planned mechanical systems, often because the mechanical teams were brought in late in the process. Lois showed that great process of all the decisions to make it schematic design. Sometimes the MEP doesn't even come in until the end of schematic design. Remediation of poorly planned mechanical systems in our project is the leading source of change orders, the leading source of cost overruns, and certainly the leading source of tension as we get into construction. Multi-unit buildings require highly efficient heat recovery, well-insulated domestic hot water, as Lois showed. And yet many architectural teams are kind of ignoring these at the critical early stages, figuring it'll get taken care of later. As a result, systems get shoehorned into what space remains rather than designed to be low cost in a space meant for them. I propose in the OPR and in your process, lay out mechanical first. Before you do a floor plan, decide on your ventilation strategy and some of your core mechanical strategies. Plan plumbing pipe links from the start. Track your links, as Lois showed that great box diagram versus the up and down risers. Start tracking that stuff in the early discussion. That's your money you're spending. You should know what you're going to spend on it by tracking it. Just as an example, you can do multi-unit passive house with local ventilation, like shown on this slide, where it's on the wall, but it needs to be on or very close to an exterior wall in every single unit. Or you can do it with a central system like this Swegan shown, or even bigger systems like the one Lois showed on Cornell. Either system works, there's merits to each, but they go in fundamentally different places in your building, and they take space in different ways in your building. And this is a decision and a conversation the owner should have before schematic design, before you start laying out units. And to wait and do this later always costs more. So your OPR should engage a passive house consultant with multi-unit experience and an MEP with passive house experience, and have them deeply involved prior to schematic design, working closely, of course, with your architect. And you should identify mechanical strategies and allot space before laying out floor plans. Okay, number 2, minimize surface area. You know, the famous book Pattern Language advised us to wrinkle the edges and turn the corners to achieve light on 2 sides. And many planning guidelines push these same sorts of ideas. These practices drive up construction costs while driving down energy performance. And to the degree you can within your planning metrics, you need to push back on these. Bays, step backs, balcony insets, and other wrinkle the edge strategies, they raise your cost twice. Once, they increase the cost of construction materials and labor. And then again, you have to offset the additional heat losses, so it's more insulation or trickier thermal bridges or trickier window installs and additional hard costs to remedy these things. The solution is to require affordable housing achieve a form factor as close as 1-to-1 as feasible given the building. It might be a little bit more than that in some cases. Count your corners and cut them. Eliminate as many wrinkles as you can. Eliminate step backs. Avoid structural cantilevers wherever possible. There might be a way to do a structure outside the building if it's a mid-rise building. Decorate the enclosure, don't decorate with the enclosure. And adopt this or a similar mantra from the very beginning, not halfway through the architectural process. Your best passive house architects will be preaching the same thing and will be completely on board. Just quickly, you know, you take a box, you got 4 corners. You make it a balcony to bump out, all of a sudden you have 8 corners. You're paying for each corner inside and out, and up to 1 extra inch of insulation. Move that over and you've got 12 corners, 20% more surface area, 2 inches of insulation. This is an example from an actual project in Vancouver where the city's requirements for those setbacks, which I would add, there are now equally height buildings all around it. So you're not really stepping back to single family homes anymore. That's 10% more surface area just with these relatively modest pieces and more than 10% more cost. We recognize you work in tough environments. This slide is from Alex Steinberger, Cascadia Partners, that these are the 4 horsemen of the zoning apocalypse, and we all work through these. Nonetheless, there are opportunities to push back on these things in modest mid-rise proposals. So again, in your OPR, set a surface area target and require the design team to achieve it. Go ahead, have some discussion with the architectural team right at the beginning about form factor, but once you set a target, you manage to it. Okay, number 3, force your facade to follow function. Glazing in lieu of design or glazing as design are the mistakes that kill energy performance and drive up costs of so many buildings. How many times do you ask for design and they show you a glass box? There's no thought gone into it, it's just another glass box. Too many teams are designing this way from the outside in and using windows to decorate the facade rather than windows that serve some function. This route creates unrealistic expectations in clients and in jurisdictions. And once you've shown it, you've got to deliver it. And you've pushed up the cost of your passive house significantly. You've pushed yourself to that upper edge right there. Look, I work for people who do some great technology work. We can make anything in passive house, but we can't make it affordable once you start drawing a glass box. Only place a window where it has a function, it has a purpose, and where it is the best solution to serve that purpose. There are legitimate purposes: daylight, views, ventilation. Force your team to answer for every window and door. What's the purpose? Does it serve the purpose? And force the group to look at the design from the inside out. You can do other things on the outside, especially with shading, but in other ways to make the building beautiful, let the windows and doors serve a purpose. Otherwise, you get this. If you don't ask for it to serve a purpose, you'll get a glass box or a whole bunch of glass boxes or a whole sky full of glass boxes. And we see these renderings again and again. If you're trying to do an affordable passive house project and your architect shows you this, my strongest suggestion is you just politely end the Zoom call and find another architect. Like, they're just not hearing you. On the other hand, if the architect is really embracing this, embracing form, embracing smart glazing, great, that's where you want to go. Remember that the glass box has no function. Small buildings need some heat gains. Large buildings like we're talking about here, they don't need heat gains. Most of the effort in the design process is to minimize heat gains. You've got enough from the inside. And look what happens when you deliver large boxes. You get all the blinds pulled down. This is a beautiful spring day in Vancouver. It's not particularly hot out, but it's just too much light. Nobody is asking for more glazing on buildings. This is one of Lois' projects, and I highly respect. This is a great example of facade. The windows are serving a purpose. Now, so many times you've seen exercise rooms where they run glazing all the way up and down to the floor, almost to an embarrassing degree. At Cornell Tech, you have this beautiful little window just at the right height to enjoy that view. It's a great example of a facade that follows the function. It has a reason for being there. It's there, but it's not overdone. And I would just take this approach to every window in the building. So specify maximum window to wall ratio. If you don't have a number, start with 25%. Fine to adjust that somewhat in consultation with your team, but have a number and manage against it. Minimize ground floor glazing, and most of all, demand that every window have a purpose. Finally, repeat what works. Almost every architectural practice is based on a set of details that repeat over and over, and you have to reinvent all of these for Passive House. I'm simply urging us to apply the same principle to all the components of the project. Many municipal planners have developed a rigid aversion to repetition. I think we need to push back on that a little bit. Repeat what works. Embrace repetition of excellent design. You can repeat details, components, wall panels, units, or entire buildings. So once you have a good set of details that work in your climate zone, if you're a building type, you can use them again and again and again. You can develop contracts with builders or enclosure engineers who've reviewed them for your previous project and will price your next project lower because they know that set of details really well. And the new building maybe changes one or two, but otherwise they stay the same. You find a window that works for your design, use it again and again. You don't need 5 different size windows. Pick one, use it again and again. In fact, extend the window to the whole wall. Find a wall panel with a window mounted in it that creates great repetition in a simple form. Use it again and again. It's a great way to minimize labor, to maximize insulation, to minimize window area. But why stop at the wall? You could do a whole module. This entire development is 2 modules, one upstairs and one downstairs, and they repeat again and again. And it made the building very affordable for a remote site where trades were hard. In fact, the building was so successful after finishing the first one, we did another one with the exact same set of plans, the exact same pieces in a different location. The second building cost approximately half the first building because so many of the design and development and procurement costs had been ironed out, and there were a few cost savings we were able to recognize when we did a second time. The third building is also very attractive, and the more buildings you do, the cheaper it gets. This is exactly what they've done to control costs in quite a few of the European Passive House projects, including the Bonstadt in Heidelberg, Germany. Now, this is a whole series of courtyard residential buildings. The internal design is the same, courtyard to courtyard. The external facades are a little bit different, but do you really care? You have a beautiful 3-bedroom Passive House apartment on a courtyard. Do you really care that 200 meters away is an identical apartment? I don't think I would. And the global winners on repetition are the Chinese Passive House developers. This is the Railway City project in Galbian, China. There are 12 of these high-rises, certified Passive House projects, exactly the same building again and again. Now, many of us may not choose to do that in our communities, but it's an example that shows the repetition creates affordability. So think wall panels, think floors, align units, repeat details, contract team for multiple projects, and where feasible, maybe do 2 buildings on site. Doesn't have to be that many in every case. Really want to thank Lois for joining me on this. I always enjoy presenting with her. I have a lot of respect for Steve Winter Associates. Thank North American Passive House Network. And thank you for listening. And I hope we've had a chance to type interactively while we've been watching this together.